Today we're going to talk about the different types of chemical reactions. So we'll go through a few of them and we'll do some more in our next lesson. We'll start off with combination or synthesis reactions. During a synthesis reaction, you form one product. So that is your key. So two things combine usually to form one thing. Sometimes it could be two elements reacting to form a compound. In this case, these are redox reactions. So the elements that are reacting, one of them is oxidized and one of them is reduced. So let's take a look at the formation of a binary ionic compound via a synthesis reaction. Remember when writing balanced chemical equations to represent each chemical involved with its correct formula. So we see that chlorine is diatomic, sodium is not, and we get the correct formula for our product, sodium chloride. Make sure to include states of matter and make sure the equation is balanced as well. So sodium is a metal. All metals are solids at room temperature except for mercury. Chlorine is a gas. Most of the diatomic molecules are gases. The exceptions are bromine, which is a liquid, and iodine is a solid. Sodium chloride is an ionic compound. All ionic compounds are solids at room temperature. Let's take a look at the formation of a binary covalent or molecular compound. So we have nitrogen and hydrogen reacting to form ammonia. Let's balance this. Both nitrogen and hydrogen are gases at room temperature. Ammonia is also a gas. If you did not know that, that information would likely be provided to you. So for ionic compounds, they're all solids at room temperature. Molecular compounds, some are solids, some are liquids, some are gases. So you would be given that information in the problem. Just going back, a generic equation I often write for these reactions looks like this. So you have some element A reacting with some other element B to produce some compound APIB. Let's take a look at another synthesis reaction. Sometimes you have a compound that reacts with an element to form a different compound. These are also redox reactions. Here's a couple examples. Balance, states of matter. Again, you would be given information regarding the states of matter of both phosphorus trichloride and phosphorus pentachloride. Here's another one. Everything here is a gas, and again, you'd want to balance this equation. And we also have two compounds reacting to form an even larger compound. These are not redox reactions. Here's a common one that you might see. Metal oxides, like calcium oxide in this example, react with carbon dioxide to produce the metal carbonate. And everything is already balanced. Here's another one you might see. Metal oxides react with water to produce metal hydroxides. Again, you'd want to balance that equation. I'll let you do that and include states of matter. So in combination or synthesis reactions, you make one product. The opposite of a synthesis reaction is known as a decomposition reaction, where you're starting off with one reactant. That is your key, your clue. One reactant, and that produces two or more products. Decomposition reactions are always endothermic, so we usually break apart a compound by using either heat. Sometimes we can use electricity, but primarily heat. So again, we can write a generic equation for this. A binary ionic compound or binary molecular compound will decompose into its elements. These are also redox reactions. Here's a couple examples. If you take mercury 2 oxide or mercuric oxide and heat it up, you will make mercury metal and oxygen. Mercury oxide is an ionic compound. It's a solid. Mercury is a liquid. Oxygen is a gas. Go ahead and balance this equation. Let's try another one. If you take water, and it can't be just pure water, it's got to have some ions in it. Don't worry about that part. Take some water and pass an electric current through it. You can break it apart into hydrogen and oxygen gas. So there's our balance equation for that one. Sometimes compounds break apart into a smaller compound along with an element. These are redox reactions. A couple examples. Chlorates, in this case it's potassium chlorate, will decompose into a chloride and oxygen gas. So again, include states of matter. Go ahead and balance that equation. Let's try another one. One you perhaps saw in Chem 1 as a demonstration. Decomposition of hydrogen peroxide. This is a reaction that can be catalyzed by the iodide ion. And again, make sure to balance that equation. I'll let you do that one. And last, for our decomposition reactions, a compound may break apart into two smaller compounds. Sometimes these are redox reactions, sometimes they are not. Here's an example. This one involves the decomposition of ammonium dichromate. This is commonly known as a volcano demonstration, volcano reaction. You can look that up, it's pretty cool. And so you produce chromium 3 oxide, water, and another element, nitrogen in this case. So breaking apart a compound into two smaller compounds, and in this case, another element as well. I'll let you put states of matter in balance. Let's try one more. A class of reactions you need to know, decomposition of carbonates. A carbonate will decompose into an oxide and carbon dioxide. I think we saw the opposite of this earlier. So again, go ahead and balance that and include states of matter. Of the types of reactions, synthesis and decomposition are probably the easiest. Where it gets a little tricky is with the displacements, also known as replacement reactions. We call these in Chem 1 the single replacements. We're going to start with that, single replacement reactions. There's lots of different types. These are always redox reactions. And how it works is a more active free element, so we have an element that's by itself, will replace a less active element that is in a compound. And you produce a different element and a different compound. Let me write a generic equation for you. So some element A reacts with some compound in solution, By, and you make So in this case, A replaces B to make a compound in solution, AY, and some other element B. You could have A replace Y, depending on what it is, to make AB, or BA, I guess would be in that case, and Y. So it just depends. Let's take a look at the metal displacement reaction. So go ahead and turn to page 145. Now, with all single replacement reactions, we need to first predict if they will even occur before we attempt to write a balanced equation. So be familiar with the activity series. The activity series will be provided to you. There's one in your book on page 146. So you don't need to memorize that, just need to know how to use it. So again, an element can replace anything below it in the list. And so, for example, lithium, if you turn to page 146, lithium's on the top there. Lithium can replace everything. Find gold. Gold can't replace anything. Platinum could replace only gold in a single replacement reaction. So elements can only replace things below them in the list. There's also a list for the halogens when we get to halogen replacement reactions. And we'll see that when we get there in just a second. So in example 4.6, we have zinc metal being placed in a solution of copper 2 sulfate. So the question is, can zinc replace copper in a compound? If we go to the activity series, we see that zinc can in fact replace copper. And so this reaction does occur. Your products will be zinc sulfate and copper metal. Turn to page 148. Another example of a single replacement reaction is a reaction between an acid and a metal. So the example here in 4.7 asks about aluminum, copper, and silver reacting with hydrochloric acid. So again, we can go to the activity series and find which of those metals is above hydrogen in the list or which is below. And then if the reaction occurs, we can write a chemical equation. So according to the activity series, it looks like only aluminum can react with hydrochloric acid. When a metal reacts with an acid, it will replace the hydrogen in the acid. And so these reactions always produce hydrogen gas. In this case, we get aluminum chloride as our soluble product and hydrogen gas. Some metals not only react with acids, but they will react with water. Now, only the most reactive metals will react with water. Which metals are the most reactive? Those are the alkali metals. So let's take a look at 4.8 on 148. I'm going to do a different one just to make it a little bit more simple, because that one there is showing calcium also reacting with water. So we can find that in the activity series too. Primarily, we're talking about the alkali metals reacting with water. Some of the alkaline earth metals can react with hot water, but we'll just stick with alkali metals. When a metal reacts with water, it will replace one of the hydrogens in water. So if you want, you can temporarily write the formula of water as HOH. So sodium reacts with water to produce sodium hydroxide and hydrogen gas. So this reaction, like the one before, also produces hydrogen gas. Last one, page 149. We have halogen displacement or halogen replacement reactions. And so we see a list there that fluorine can replace any other halogen in a compound, and iodine cannot replace anything. So fluorine can replace anything. Chlorine cannot replace fluorine, but it can replace both bromine and iodine, and so on. So let's take a look at an example. So in this case, the chlorine, being a halogen or nonmetal, is going to replace the halogen or nonmetal in the compound. So chlorine and iodine trade places. Your products are sodium chloride and solid iodine. All right, practice time. Go ahead and turn to page 162. Take a look at question number 81. And I'm going to change the acid there just to make it a little easier. It gets a little complicated with sulfuric acid. So just go ahead and change that to hydrochloric acid. So which of the following would displace hydrogen when a piece of metal is dropped into dilute hydrochloric solution? And for any metals that do react with hydrochloric acid, write the balance equation. We want the total, or what we called in the notes earlier, the formula unit equation. So the whole thing, so balance total ionic, net ionic equation for the reaction. So three equations: the molecular or formula unit equation, the ionic equation, and the net ionic equation. Go ahead and pause, please. So the only metal listed there that will displace the hydrogen from hydrochloric acid is zinc. Make sure you get the correct states of matter for everything. It will affect your ionic and net ionic equations. Zinc chloride I wrote as aqueous. How do you know? That's right, solubility rules. So our ionic equation, written as such, I balance from the original equation. Because this is a redox reaction, I want both mass and charge to balance. Spectator ion is chloride, and so we see the net ionic equation there. The zinc in this reaction is being oxidized, and the hydrogen ions are being reduced. All right, go ahead and take a look at page 162, number 85. I think in your notes it might say number 81. Please do number 85. Similar problem, except this time we're looking at reactions between metals and water. Go ahead and write the overall balanced chemical equation, the ionic equation, and the net ionic equation. Pause the video. All right, be careful with this one. We have sodium metal that reacts with water to produce sodium hydroxide and hydrogen. Sodium hydroxide is a strong base. So when we write our ionic and net ionic equations, we need to show it dissociated. If it was a weak base that formed, we would not show it dissociated. So be careful. We mentioned last lesson with the weak acids and weak bases. In this case, the net ionic equation is the same as the ionic. If that's the case on a homework assignment or test, you can just go ahead and put same as ionic. Sometimes, in fact, there are no net ionic and ionic equations. In that case, right, no ionic and net ionic equations. Now we're going to skip number 89 for now. If you want to do that on your own, that is fine. I do, though, want you to do number 91. Go ahead and pause the video, work on that, and we'll go over the answers. So for letter A, copper cannot replace magnesium in a compound, so that reaction does not occur. Letter B, yes, nickel can replace copper in a compound. C, no, copper cannot replace hydrogen in an acid. It does in some acids, actually. It's a little bit tricky there. And then letter D, yes, magnesium can replace the hydrogen in water. Notice the water there, it's water as a gas, so we're assuming that this is steam, I suppose. And so, yes, that reaction would occur. That concludes this lesson. Next time we will talk about double replacement reactions. We have several examples of those. Thanks for watching.